Yesterday we talked in 2.6a of functions that have asymptotes. All the functions yesterday, their numerators happen to be smaller than the denominators. Well, today we're going to flip that a little bit. Today, all for 2.6b, our functions are going to have larger numerators than their denominators, specifically by 1. So let's give an example here. If I had a negative, so this is a negative function here, x squared plus 5 over x plus 3. Okay, so this is a special case, right? Because we're like, well, what's really going on here? If before, you kind of have kind of a straight line thing going on with asymptotes, but if you think about it logically, right? If we get an x squared and we divide that by an x or a negative, isn't that negative x? So it shouldn't be not of a surprise to you that instead of just all straight asymptotes, we are going to now have an angular asymptote here, and I'm going to show you how to do that. First things first, let's talk about our vertical asymptotes. Our vertical asymptotes always is going to stay the same because x cannot equal, right? Our vertical asymptote, we set our denominator x plus 3 equals 0. Well, x equals negative 3. That is our vertical asymptote. And then let's think about how to find our angular line as our second asymptote. So we no longer have a pure horizontal line as a asymptote. Now we have an angular line, and to do that, in this case and in every case, we are going to use synthetic division. We are going to take this negative 3 here in the bottom, and then we're going to synthetic divide the top. And since we have this negative x squared, right, because we have a negative in front, it's actually negative x squared minus 5. So our coefficients are actually negative 1, 0, and negative 5. So then we're just going to synthetically divide. We have negative 1. This becomes 3. This is 3. And then this becomes what? Negative 9. And it actually does not matter what our remainder is. We only want the other part of the synthetic division, but our remainder is negative 14. So here, our line is actually negative x plus 3. So that is our angular line linear asymptote. So I'm going to use this negative x plus 3 and x equals negative 3 to graph up here. So let's see here. X equals negative 3. I'm going to do a dotted line at negative 3. That is our x equals negative 3. Back here, negative x plus 3. That means it crosses at positive 3. Negative x, that means it has a slope of negative 1. So it kind of goes just like this. Now here we have a negative function. Once again, our negative function, before, like, just a little reminder of yesterday, our positive function, I'm going to do this in blue, is this here. Our negative function, I'm going to do that in green, is this here. So now our negative function is going to be kind of like that. However, before I graph it, I kind of want to know what my y-intercept is, right? So looking here at my original function, my y-intercept should be what, negative 5/3? So y, see here, y-intercept should be what, remember our coefficient is negative, so negative 5 and thirds. So here, to graph it, we're going to go to our graph here, and negative 5/3 is about here per se. So now just to graph it, it should kind of go like maybe like that, and maybe like that, and then we probably don't see the other part here, but it's somewhere up here. If this graph had extended more further up, that the line would have gone all the way up here and the line would have gone there, and it would have looked more like that. Let's do another example here off to the side. What if we had, instead of just a regular x squared over an x, what if we had an x cubed, right, over a 2x squared minus 8? Well, it will graph very similar. However, to find your slope here, what we do is we just take the coefficients in front of our x cubed and our x squared, and this should be, our line should be y equals, there's just one x and then a 2 in front, so that is our line. Because of the x cubed and the x squared, we do not synthetically divide, we just take the coefficients in front. So there is just a 1x on top and a 2x squared, and the x squared cancels out and we only get a x over 2. And then of course, to get our horizontal, our vertical asymptote, we need to set the bottom equal to 0, right? That is always will be our asymptote, so I'm going to add 8 to both sides. 2x squared equals 8, divide by 2, x squared equals 4. Well, since we square root this, we actually have 2, right? X can equal plus or minus 2 for our asymptote. So let me graph that over here. So we have a positive and a negative 2. So here's a positive and negative 2 for our horizontal vertical asymptote. And then we have a y equals x divided by 2. That crosses at the origin. If we had that line, the slope is 1/2, so it rises, runs 2. That's a positive 1/2. So if we did a dot, 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 that is how we would set that up. And since it is positive, down here, we're going to use the blue format. So we will start at the bottom corner here, and it should look like that. And then we kind of want, well, let's see where it crosses the x and y axis here. So we go back to our functions here. Well, it crosses at the y-intercept. We take the coefficient on top. Well, that's a 0, and the negative 8. So this is our y-intercept, and since our y-intercept is at 0, then for our x-intercept, remember we just take the numerator, set that equal to 0. Well, x then is equal to 0. So our y-intercept and our x-intercept are one and the same. They are 0 and 0. So we can go just this, like this, and then we go down, crossing at 0, 0, like so. And then we fill in the very last part here to dip up. So it's kind of like that all the way, and how we would graph and find all of that information.